Hey guys, it's Mrs. Kerr here. Today's lesson I'm going to talk to you about our last remaining conic section that we have to learn about, which is parabolas. So you might be like, well, I already learned about parabolas in Algebra 2 or reviewed them earlier in the year in this class, but our definition of a parabola and how we write the equations and how we think about it is going to look much different in this section than it has before. So our definition of a parabola is it's the set of all points equidistant from a focus and a directrix. So these are things we have not talked about before. Okay, so I've just drawn a parabola here for you to see. We already know a parabola has a vertex. Okay, that's kind of old news. But now we're going to have it also having a focus and a directrix that define where all these points would go. Then the parabola, every single point, anywhere along this parabola, and I've drawn one in right here, anywhere I pick a point, it's going to be the same distance for me to go to that point to the focus and to the directrix. Okay, so any point I pick is going to be the same distance from here as it is to here. So that's our new working definition of a parabola. Another thing that we'll talk about is here's your vertex. Your vertex is always in the middle between your focus and your directrix. So the focus and the directrix are the same distance away from the vertex. So before we do examples, I'm just going to show you this sheet that kind of does a good job of summarizing all the parabola stuff. And it's kind of overwhelming when you first look at it, but and I will be posting this on Google Classroom too, so that you can reference it. So let's start with this part right here. Okay, this is our general equation of conics. So how do we know if it's a parabola, right? We've talked about how you know if it's a ellipse, hyperbola, circle. You know it's a parabola if it only has one squared term. So in other words, either the A is 0 or C is 0, but they can't both be 0. If they were both 0, it would just be linear. Okay, so just remember, parabolas only have one squared term in the conic, the generic conic formula. Okay, and then parabolas. Basically, we can have parabolas that either open up or down, or open left or right. So these two pictures kind of show you what they would look like. So if the parabola opens up or down, okay, this is what our equation is going to look like. X minus h squared equals 4p times y minus k. So how do we get the features from this equation? Well, the vertex is always at h comma k. It's the opposite sign of both of the things with the x and y. So I would start by saying my vertex is at hk. Then we have this new thing here, this p. So this p is the focal radius. It's how far you move from the vertex to the focus. And then you move that same distance, but in the opposite direction to get to the directrix. So I would start at my vertex, and then if my p is positive, that means I would move up to get to the focus. If I move up to get to the focus, I'd move down to get to the directrix. Okay. If my p was negative, I'd start at my vertex and I'd move down to get to the focus and up to get to the directrix. So if the p is positive, it opens up. If the p is negative, it opens down. An important thing to remember is that your focus is always inside your parabola. The directrix is always outside. And then the focus you could just write as an ordered pair by adding the focal radius to the y value of the vertex. Since you're going up, you're going in the y direction. And then you could write an equation for this directrix, which is a horizontal line, by subtracting the focal radius from the y value of the vertex. A lot of times it helps to draw a picture too to help you with this, which I'll show you. So that's if it opens up or down. If it opens left or right, this is what your equation looks like. So the y is squared. Y minus k squared equals 4p times x minus h. So if the x is squared, it's up or down. If the y is squared, it's left or right. Vertex is still at h comma k. And then you would start at your vertex, and then now if the p is positive here, it would open to the right. You'd move in a positive x direction. So you'd move this way to get to the focus and this way to get to the directrix. This time your directrix is a vertical line. If the p was negative, it would be just the opposite. You'd start here and go this way to get to the focus and this way to get to the directrix. And then this is just showing like how you could write to get to the focus, you would just add the focal radius to the x value of the vertex, since it opens in the x direction. And then to write the equation of the directrix, you could subtract the focal radius from the x value of the vertex. As I kind of mentioned, drawing a picture really helps too. So I know that seems like a lot. And like I said, I'll post this on Google Classroom. But that's kind of the summary of what the equations look like. So now we're going to do some examples. So our first example says to write the equation of a parabola with a vertex at 3, 2 and a focus at 1, 2. Okay, so the first thing I'm going to do is just draw a quick sketch of what this would look like. The vertex is at 3, 2. Okay, it doesn't have to be a perfect sketch. And the focus is at 1, 2. Okay, so if this is my vertex, so this is just put V, and this is the focus. Remember, from these pictures, the focus is always inside the parabola. So based on that, I know my parabola would have to open this way. Okay, so that's a sketch of what it would look like. So since it opens left or right, we know it's going to be of this form. Okay, y minus k squared equals 4p times x minus h. So I'm just going to write that down. Y minus k squared equals 4p times x minus h. Okay. Now we just have to figure out the h, the k, and the p. Well, the h and the k, remember, are the vertex. So that's easy in this one because it's given to you. It's 3, 2. Just make sure you put the y with the y and the x with the x. So this is going to be y minus 2 squared equals 4p, and that's going to be x minus 3. How do I figure out the p? So remember, the p is the distance that you move from the vertex to the focus. Okay, so right here, how many spaces do I have to go from the vertex to the focus? I move 2, but I'm moving 2 in a negative direction because I'm going backwards. If I was going this way, it would be a positive 2. So my p is negative 2. So then, and it's always 4p, 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 4p. So in my equation, I'm going to have y minus 2 squared, and then I'm not going to put in p here, it's 4 times p. So since my p is negative 2, 4 times negative 2, this is going to be negative 8 times x minus 3. So just remember, the p is how far you move from the vertex to the focus. And it can be positive or negative depending if you're moving in a positive or negative direction. Okay, let's do our next example. The next example says write the equation of a parabola with a vertex at the origin and a directrix at y equals 3. Okay, so same thing I did in the other one. I'm going to just go ahead and draw a quick picture. It just needs to be a rough sketch. Okay, with the vertex is at the origin. So there's the vertex. And the directrix is at y equals 3. So y equals 3 is a horizontal line. Okay. So first thing is, how do I know which way this is going to open? So remember, the focus is always inside the parabola. Okay. So since the directrix is this way, that must mean the focus is this way. Okay. And remember, the focus and the directrix are the same distance away from the vertex, just in opposite directions. So here, since my directrix is up here, I have to go 3 to get to the directrix. That means I would just move down 3 to get to the focus. And that guy would open down. Again, this is just a rough sketch. So that's a sketch of what it would look like. Now we got to write our equation. This is an open up or down one. So if it opens up or down, remember the x is squared. So I'm just going to write the generic equation. Okay, so it's x minus h squared equals 4p times y minus k. Okay, and then we're going to plug in what we know. Okay, so we know the h and the k are 0, 0 here. So that makes it easy. Okay, so I'm just going to write that so we know. Let me just write it up here. So we know HK is 0, 0, okay, because they tell us the vertex. And then what's the focal radius? Remember, the focal radius is how far I go from the vertex to the focus. So I know I move 3, but since I'm moving down, that's a negative 3. Okay, so if you're moving down, it's negative. If you're moving up, it's positive. So my P is negative 3. So now I just plug into the equation what I know. HK is 0, 0. So this is going to be x squared equals, and remember, it's always 4p, 4p, 4p. My p is negative 3, so this is going to be a negative 12. And then it's just going to be y because it's y minus 0. So that would be my equation. Okay, so far we've just had to write the equations. If I give you some of the features, now I'm going to give you an equation and we're going to have to sketch the graph and find the features. So let's do this one. It says find the vertex, focus, and directrix of the parabola and sketch its graph. Okay, so I have x squared plus 8y equals 0. So the first thing I notice about this is it's not in the form I want it to be. Okay, it does not look like that or like that. Okay, so in both of these forms, whatever is squared, it's by itself, and the other stuff is on the other side. So what I'm going to do to start this one off is I am going to subtract 8y. So now I get x squared equals negative 8y. So now, even though it might look a little bit weird, it's still in this form. Okay, it's kind of like the one we just did up there. So looking at this, I know there's nothing subtracted with the x. There's nothing subtracted from the y. So the vertex here is at 0, 0. Okay, and sometimes it helps to just draw a little sketch. So the vertex is at 0, 0. Okay, so we know that. And then remember, whatever this number is out front is always equal to 4p, 4p, 4p. So in this case, it's a negative 8. So we know negative 8 is equal to 4p. Well, if we want to figure out what p is, we could just divide both sides by 4. So my p is negative 2. So remember, your focal radius, your p, is how far you move from the vertex to the focus. So if my vertex is here, at the origin, okay, and I know this is an open up or down parabola because the x is squared. Okay, if the y is squared, it opens left or right. So since the x is squared, it's an up or down. So since my p is negative 2, I'm going to start at my vertex and I'm going to move down 2. There is my focus. So the order pair for that would be 0, negative 2. And then if my focus is down there, my directrix is the same distance away in the opposite direction. So I would start here and go up 2. Okay. And remember, this is a horizontal line I'm drawing, so this would be at y equals 2. So y equals 2 is the directrix, 0, negative 2 is the focus, and then you could just draw a sketch from there. Okay. All right, we're going to do a couple more now where we have to complete the square, okay, because we have not had to do that yet, but we know we've had to do that with our other conic sections. So example 4 here says find the vertex, focus, and directrix of the parabola and sketch its graph. Okay, so this one, you can see, first of all, we know it's a parabola because we have something squared, okay? We have the y squared. Now, what makes this one different versus the one we just did is this one we only had x squared, so we were able to move that 8y over, and then we had x squared equals negative 8y. The problem with this one is we have y squared and negative 4y. So this is one where we're going to have to complete the square on the y so that it turns into something like this, a perfect square trinomial. Okay, so the first thing I'm going to do is I'm going to add 4x to both sides. Okay, to get that guy. So then I get y squared minus 4y equals 4x. Okay. So again, this one, I can't have this. This is not what it looks like. So now I'm going to complete the square. So I'm going to write this as y squared minus 4y plus my little blank equals 4x. Okay, whatever I add there, I'm going to have to add there. So my magic number here, I take half of my b and square it. We've done this enough that You guys probably have that down. So half of negative 4 is negative 2. Negative 2 squared is 4. So if I add 4 here, guess what? I've got to add 4 there. Now I just factor this, guys. So this is going to factor into y minus 2 squared. Okay, now this side, okay, we've got to go back and look at our equation. So our equation, the way we want it to look, actually we're doing this version of it, is right now we have 4x plus 4. Okay, we can't have that. We just have to have x plus or minus something in parentheses. So what do we have to do is we always have to factor out the coefficient of the x. It's kind of like a GCF, but it has to be whatever the coefficient of the x is. So I'm going to factor out the 4 out of both of these, and that's going to leave me with x plus 1. Okay, so that's the completing the square. This is my equation. And now we need to graph it. Okay, and I'm going to do that right here because I did not leave myself enough space. Okay, so as far as sketching the graph, first of all, let's identify the vertex. So vertex, remember, is always opposite of both of these. So the vertex is going to be at negative 1, 2. Okay, so I'm just going to draw. Again, it does not need to be a perfect sketch. Oops. Negative 1, 2. Okay, so this is at negative 1, 2. There's my vertex. Okay, the next thing I want to do is I want to decide which way it opens. Is this an up-down or a left-right? Well, the y is squared. Okay, so if the y is squared, we know it opens left or right. So how do I figure out where my focus is and where my directrix is? That's by looking at this number here. Okay, remember the number out front is always equal to 4p, 4p, 4p. So I know that 4 is equal to 4p. If I want to solve for p, I'm going to divide by 4. So my p is 1. My focal radius is 1. So since it opens left or right, that means I'm going to start from the vertex to go to the focus. I'm going to move 1 to the right. Okay, so this is my, whoops, it would help if I could spell. This is my focus at 0, 2. And then I would move the same distance, but in the opposite direction. So I'm going to move 1 backwards. This is my directrix. Okay, and this is a vertical line, so this would be at x equals negative 2. Okay, and then it's going to open the direction of the focus. Okay, so the main thing is just to remember that this guy is always equal to 4p. Okay, and remember, once you start at the vertex, that's how you move to the focus. Okay, and I moved to the right because we know it was opening left or right. And then I moved backwards to get to the directrix. Okay. All right, and we're going to do one more, convert to standard form. So on this one, we are not going to actually graph it because you'll see it gets kind of ugly, but we're just going to put it in the graphing form and identify the features. Okay, so this one is kind of like this one. And again, I know this is a parabola because I only have one square term. So what I'm going to have to do in this one is complete the square on the x because I have an x squared and an x. So I'm going to start off by subtracting this 3 over. So that's going to give me y minus 3 equals negative 2x squared plus 20x. Okay, now I'm going to complete the square. So y minus 3. So here, remember, if you have something in front, you have to factor that out before you complete the square. So this is going to be negative 2x squared. If I take a negative 2 out of this, it would turn into a negative 10. Okay, magic number here, take half of negative 10, which is negative 5. Negative 5 squared is 25. Now, remember, I can't just add 25 to the other side here. Why? Because that negative 2 applies. So this is really negative 2 times 25, which is a negative 50. So I'm going to subtract 50 from that side. Okay, so just be careful. So on this side, I have y minus negative 3 minus 50 is negative 53. And this side would be negative 2, and this would be x minus 5 squared. Okay, so you might be thinking, okay, cool, we completed the square. But if we look at our equation, okay, and this is going to be one like this since the x is squared, you can't have something in front of the squared thing. So like right here, we have that -2 in front of the squared part. The number always has to be in front of the non-squared part, and that tells you your focal radius. So what I'm going to have to do from here is I'm going to have to divide both sides by -2. So this is just going to leave me with x minus 5 squared. And then I'm not actually going to divide each of these by -2. Okay, if I'm dividing by -2, I'm just going to put that negative, write that as a -1/2 out front. Okay, and then, so this is my equation. So just if you do wind up with something, a coefficient, you have to, divide it over. And then here, my vertex. Vertex is opposite x, opposite y. The vertex would be 5, 53, okay, which is, again, why we're not graphing this one. This one opens up or down since the x is squared. So we would know that if we wanted to sketch it. And then our p, so remember, this guy here is always equal to 4p. So -1/2 is equal to 4p. So then I would have to divide by 4. So my p is -1/8. Okay, so sometimes you do get a fraction for the focal radius, and that just has to do with the fact that the way that the equation works, it's always a 4p out front. So in this case, I would start at the vertex, which is at 553, and then I would move down -1/8 to get to the focus, and up 1/8 to get to the directrix. So this guy we know would open down. Okay, guys, so I know there's a lot of new stuff with the parabolas. So like I said, I will be sending out this little sheet that you can reference, and then just reach out to us if you have any questions. All right, we'll talk to you guys later.